Hi, I'm Corey O'Daniel, the CEO and co-founder of Massdriver. Massdriver is a unified self-service plane for managing infrastructure and applications. It allows engineers to quickly deploy golden paths for their applications, whether they run on serverless, containers, or in virtual machines. Today we're going to build a simple chat application running on Kubernetes using Postgres for storage. We'll quickly configure a VPC, and then we can add our database. On the left side of the screen here, you'll see our bundle manager. Massdriver develops a number of these bundles for teams that don't have operational expertise or operations staff. If you do have your own operations staff, you can extend the platform. We'll go ahead and connect this database to the VPC, add our Kubernetes cluster, and we'll be ready to start configuring our application. To expose our application to the internet, we'll need a DNS name. Massdriver supports creating DNS zones or importing DNS zones from AWS, Azure, and GCP. We're going to import a zone from AWS. We use the credential we've already attached to our account and select the Massdriver sandbox domain at the bottom. Now we'll attach this to our Kubernetes cluster. By enabling ingress, we're allowing traffic to flow into our cluster, and setting this zone, we'll be able to automatically register TLS certificates as well as subdomains for our application. We'll go ahead and deploy this Kubernetes cluster with those updates, and we should be ready to configure our application to run on Massdriver. We'll use the Mass CLI to package our application. We'll call this Phoenix Chat Example and give it a description. We'll then be presented with a number of templates. Massdriver templates allow your application to run in serverless functions, VMs, or in container orchestration systems like Kubernetes. They configure IAM, KMS, and all the DevOps bits so you can focus on writing features. After selecting a template, you'll be presented with a number of dependencies that your application needs, whether it's buckets, queues, or databases. We'll type Postgres and select Postgres authentication as one of the things our application will need to run. We'll then be presented with a prompt for a name for this Postgres database. We'll just call it Postgres for now. We'll see this later in our configuration. And there we go. Our application template's been generated, and we can go ahead, open this in VS Code, and start looking at our configuration. Massdriver environment variables are a little bit different. Massdriver's parameter and configuration system is based on JSON schema, which gives us rich descriptions, types, and validations. Massdriver environment variables pull from those parameter and connection values. JQ expressions are used to pull parameter and connection information from your infrastructure and inject it directly into your application's environment variables. On line 11, you can see that we're pulling the username, hostname, and password from the Postgres instance and directly injecting it into the database URL. We didn't set a HashiCorp vault. Nobody copied and pasted the password. No human has seen this value. It just goes directly into your environment variables. Similarly, you can do the same thing with IAM policies for SQS, topics, and other cloud resources. Let's add a new parameter for log level and make it an enumeration that expects error, warn, or info. This will present a drop-down in the user interface for people to select the log level, and it makes it impossible for somebody to accidentally enter the wrong value for this environment variable. All of JSON schema's validations are available to your parameters in Massdriver. The last thing we'll look at in the configuration is your connections. You can see that we are required to have a Kubernetes cluster and a Postgres instance to run this application. There's also a few optional connections: AWS, GCP, and Azure. This template configured these optional connections and can respond to what cloud this Kubernetes application has been deployed into. If it ends up in AWS, it'll create an IAM role. If it ends up in GCP, it'll create a service account. And using the policies we saw above, it'll bind the policies to that service account or IAM role in the correct cloud account. Let's go ahead and publish our application bundle. That was pretty easy. And now our application will show up in the sidebar. Similarly, if you built your own infrastructure components, you could publish them in the same way. We'll drop this onto our canvas, call it Phoenix Chat, and we'll go ahead and connect it to our Kubernetes cluster, Drawing this line using that connection configures continuous delivery, which you can trigger from your GitHub Actions or GitLab using our CLI. And drawing the line from this database to the application will wire those environment variables based on the JQ expressions we saw earlier. The form presented here is what we configured in the parameter section of that config file we were just looking at. This is 100% customizable by you, the infrastructure or application bundle manager. We're going to go ahead and set some CPU and memory limits here. We'll enable ingress and pick a host name for this application. We should see it running in just a moment. And there it is. The DNS name was registered, ingress was routed to this application, and the TLS certificate was automatically registered and will be renewed using Let's Encrypt. Massdriver bundles also include automated alerting and monitoring. You can see this Postgres instance here has a number of metrics that are already being reported. When it experiences an issue, a couple of things will happen. The cloud will turn red, the metric will be highlighted with the value, and you'll also receive an email that there's some sort of issue with this piece of infrastructure with a link taking you right back to the diagram where the problem's occurring. Massdriver also supports parity management. A project in Massdriver acts as a blueprint that can be replicated across environments like staging and production, or across regions like production US and production EU. You can see here the infrastructure diagram is exactly the same, but the scale and authentication used for each environment can differ. This allows you to have a high-scale production environment and a low-scale staging environment with exact parity in the layout of your infrastructure and applications. We'll go ahead and configure this Postgres database and Kubernetes cluster for this EU region, and then we'll deploy our application, and we'll see that we have a US and an EU-based chat application running. We'll add another subdomain for our EU chat instance, hit deploy, and this application should come up in just a minute, and we'll be able to see an additional version of this application running in the EU. Okay, and here's the EU instance of our chat application. I'll go ahead and send a message here, switch back to the US version, and you can see that it is a completely isolated version of the application. Parity isn't the only way to interact with two different environments in Massdriver. You can also visually compare the differences between prod and prod EU, prod and staging. Any region or environment that you've configured in Massdriver, you can quickly compare to another. You can see differences in instance size, database version, allocated storage, compute, Kubernetes version, IAM roles, and host names. Anything that you've configured in Massdriver, you can quickly spot the differences between two different regions that Massdriver is managing. Thanks for watching. Check out more at massdriver.cloud.